we're given a triangle, whether we're going to be using the law of sines or the law of cosines to solve it. Because between the two of them, everything is solvable. I mean, every triangle that exists is solvable. So let's suppose that we have this situation. And we want to solve that triangle. Or let's not even solve the whole thing. Let's just say we want to find side B. All right? We want to find a piece of the triangle. We want to find side B. Would this be a law of sines situation or a law of cosines situation? This would be a law of cosines. How do we tell? If you have a matched set, and by that I mean angle B inside B, angle C inside C, angle A inside A. If you have a pair, then you're going to use the law of sines every time. Because remember how the law of sines works? It's a proportion. If you have that pair, that's what you're going to go with. I do not have a pair here. I have angle B, but I don't have side B. I have side C, but I don't have angle C. So I'm going to use the law of cosines. So what's the law of cosines going to look like? B squared equals 12 squared plus 14 squared minus 2 times 12 times 14 times the cosine of 58. And this is the kind we really like because we can just type this right in. All we have to remember to do when we type it in is, after we get all that figured out, remember you have to square root it, right? So what did you get for side B? Everybody should have a calculator out. Everybody should be pushing buttons so that we don't have any whining and complaining on test day. I'm not getting the right answer. I don't know what's wrong. We're practicing right now. What? 12.73 is what I got too. Good. So side B is 12.73. All right, so okay, so our job was to find side B, we did it. All right, let's look at this situation. And let's suppose we want to find angle C. Our job is to find angle C. There are other things we could be finding, I'm just picking one. Find angle C. All right, so take a look at it. To find any piece of any triangle, you're going to use either the law of sines or the law of cosines. All right, so which one seems appropriate in this problem? This would be sines because look what we have right here, right? When you have that, you're always going to set up your law of sines. So sine 58 over 14 equals sine C over 12. Why are the antennae going up? Because there might be more than one answer. Now maybe there'll be one, maybe there'll be two, maybe there'll be none. But anytime I set up the law of sines and I'm searching for an angle, I got to be on the lookout when I do that at the very beginning of the problem. So here we go. I'm going to go ahead and figure out what angle C could be. So 12 sine 58 divided by 14. Now when I type that in, I get a decimal, don't I? The decimal is not the answer. I need the angle. So I have to what? Second sign that decimal. And I got 46.63. Now, remember, anytime you're using the law of sines to find an angle in the beginning of the problem, there might be a second possible angle C. One answer is 46. We got it. If there is another answer, what would it be? 180 minus this one. So that would be 133.37. So if there is another answer, it's 133.37. Well, does that make sense? Look, you were given the angle 58. That was given. Could that one be 133? No. So this problem has just one angle C, and it's the first one you found, 46.63. Okay? Now, we have one more thing to talk about in this little unit, and that is triangle area. So when I say triangle area, what pops into your head? 1/2 base times height. Of course, you've done that since you were a little kid. 1/2 base times height. It is absolute fact. It works. It's awesome. What's the issue? Why am I not just jumping into doing 1/2 base times height right here?
We have the base, but we don't have the height.
Exactly, Patty. And that is very often the issue, because when we discuss triangles, we are usually discussing sides and angles, not altitudes. So we could find the altitude, we could drop a perpendicular, use some right triangle trigonometry and figure that out. But as it turns out, there are some shorter, and that will always work, okay? If you want to go to that extra effort, it will always work. But there are a couple other ways of finding area for triangles that are very, very fast and very, very handy. So let's talk about the first one. The area of this triangle, I'm just going to throw some numbers up here and then we're going to talk about where I got them, is this. So in other words, if I were to multiply these four numbers together and take the square root, I would have the exact area of that triangle. Now, where did those numbers come from? Well, this formula is actually called Hero's formula. The guy's name was actually Heron of Alexandria, one of those really smart ancient mathematicians. But it's been abbreviated to Hero's formula. And it says that to find the area of a triangle, you take the semi-perimeter. Now, we all know what perimeter is, right? What's perimeter?
All the sides.
All the sides added up. So what's 15, 17, and 20 all added up? 52. Now, semi-perimeter. What do you think we mean by semi-perimeter? Half of it. So the perimeter is 52. Half of it is 26. So that's where that number came from. Now, I take that number minus each side. So I got 6 because I took 26 minus 20. And then I took 26 minus 17. And then I took 26 minus 15. So to get the area, if you happen to know all three sides, if your given is all three sides, to get the area, all you have to do is find your semi-perimeter. So add them up, divide by 2, half the perimeter, and then take that number minus each side. And we just type them all in and take the square root. I got 124.27. How does that sound? Is that okay, Antonia?
Do you have to prove it's a triangle first, or?
What do you mean, prove it's a triangle first?
Yeah, sometimes if it, like in the book, it will give you like a triangle, and it'll say like find the angles to prove it's a triangle, and then use Hero's formula.
Okay, the thing, if it's not a triangle, that's gonna come out right here in Hero's formula, because if it's not a triangle, the sides aren't gonna be right, and when you do your subtraction, you're either gonna get a 0 or a negative number, and that will mean you have no triangle. So no, Hero's formula will catch that. Okay, so Hero's formula works great if we know all 3 sides of the triangle. If you don't know all 3 sides, let's go back to the problem we just had up here where this was 12, this was 58, and this was 14 or something like that. If I said find the area of that one, Hero's formula isn't going to be so great because why? I don't know the 3rd side. Now, could I find the 3rd side? Yes, using the law of cosines. We did that a minute ago. If I did that, though, keep in mind that this would be whatever, some rounded off number, right? And then when you calculated the semi-perimeter, that rounded off number would be in there, and it would be in here, and here, and here, and in one of these. So in other words, what I'm trying to tell you is, if you found side B or whatever, and rounded it off, that's gonna show up a whole bunch of places in your area formula, so it probably isn't a good idea. Doable, yeah, but probably not a good idea. Luckily, there is another area formula, probably the one we use the most of all, and it says that area is 1/2 side times sine of included angle. 1/2 side, sine. Now by included angle, do you remember from geometry, I mean the angle that is between the 2 sides? So in other words, if I had this situation, this is not the included angle. Do you see that? This would be the included angle. In order to use this formula, 1/2 side, sine, you have to have the included angle. Well, I do. So I'm golden. My area for this triangle is 1/2 times 12 times 14 times the sine of 58. I don't need to do any work or anything. I just type it in. 1/2 side times sine of included angle. And that area is 71.24. Okay? All right, that packet I just gave you, let's look at the front page of that. Let's practice a couple here. All right, Lowell found a piece of paper in the shape of a parallelogram. All right, everybody knows what a parallelogram is, right? Opposite, quadrilateral, opposite sides parallel and congruent. The sides of the parallelogram are 10 and 14. The longer diagonal, now can you tell by looking at the picture, there are 2 diagonals obviously, and one of them will be longer than the other one. Just by eyeballing it, you can see this is going to be the longer diagonal, and it is 16. Find the area of the parallelogram. Don't make it hard. What's your thought?
Find the area of one triangle.
Find the area of one triangle. And since I know all three sides of the triangle, I'm looking at the top one or the bottom one, it doesn't matter. Since I know all three sides, how will I find the area? Probably the fastest, quickest way. Hero's formula. So my area of the triangle will be a big square root. 4 numbers under the square root. The first one is semi-perimeter. So the semi-perimeter would be 20, because the perimeter of that triangle is 40. So I have 20. Now take 20 minus each side. So 10 times 6 times 4. And we will have the area of that triangle. Did you get 69? Okay, but remember, that's the area of the triangle. So to get the area of the parallelogram, we have to take 2 times that. Just take times 2, and it's 138.56, and was it inches? Yep, square inches. Easy enough? Mr. Mauger bought a triangular piece of fabric with sides of 12, 15, and 11. The fabric cost 43 inches per square inch, 43 cents per square inch. How much will Mr. Mauger owe? So he's got his little triangle here. That's 12, 15, and 11. And we will have to figure out how much he's going to have to pay for it. Alright, so what do we need to do first? Find the area, right? We need to know how much fabric he actually bought. So again, since we know all three sides, we'll do Hero's formula. And Hero's formula says what? Semi-perimeter would be 19 times 7 times 8 times 4. So whatever that is going to be the area of the triangle. Now, how do we figure out how much money he's going to have to pay for this fabric? Times the answer by 0.43. And he is going to pay $28.05. Is that what you got? All right. That side, find side B. Given what we've been given, we're going to find side B, all right? So you're looking at it, you're not doing area, you're just finding side B. And you got to figure out if this is going to be a law of sines or cosines situation. So what's your thought on that? Law of sines or cosines? Sines, because of this right here. Sine 53 over 12, right there. If you have that right there, you're going to do the law of sines. Okay, but I need angle B.
This one's 58.
Oh, this is 58?
Yeah.
Thank you. That will make a difference. In angle B also, right? Did you get 50 for angle B? I need angle B if I'm going to find side B. Would you agree? Because I'm going to say sine 50 over B. Now, is this one of those cases where I'm going to have to worry about a second answer? No, those second answers only happen when you're looking for an angle, right? And I'm not. I'm looking for a side. So 12 sine 50 over sine 58 should be the answer to the problem. And did you get 10.84? Issues? Alright, now we've got another one, and this time we are finding side C. So the first thing you do is sit back and say, okay, I'm going to set up a law sign or cosines here. Which one is it? Definitely cosines. So C squared equals what? 10 squared plus 12 squared minus 2 times 10 times 12 times cosine 82. On these guys, do not forget to take the square root, right? I got 14.51. Issues? Good? Everybody gave the same answer I am? Some sign of life would be awesome.
Yes.
Yes. All right, next, last, on this page anyway. All right, this time we want to find angle C. So again, we stand back. First thing we got to decide is, I'm finding a piece of a triangle. I'm always going to use either the law signs or cosines. And since I've got the 38 and the 9, I'm going to say sine 38 over 9. That's going to be the law signs. Sine C over 10.
So we look for another angle.
Yep. Beep, beep, beep. Antenna straight up. We know we're on alert. We're going to go ahead and figure out our first answer. For my first answer, I got 43.16. Did you?
Yeah.
Now, what that means is, if there is a second answer, that second angle C will be 136.84. Everybody's typing in, everybody's getting these numbers, right? Does that make sense? Is it going to be possible to have a 136 and a 38? Yeah, it'd be a weird shaped triangle, but it would be possible to do that. So the question was, find the measure of angle C. You have two answers. Angle C is either this or it is this. Two angle C's.
Did you get like a domain error on your calculator when you did it?
That means there are no triangles possible. No triangles possible. All right, I want you to look at the next page. It says find, number one, Find the area of a regular pentagon inscribed in a circle with a radius of 5. Okay, this brings back memories of geometry. Find the area of a regular pentagon. What does that mean? Regular pentagon. 5 sides. And regular means all the sides and angles are congruent. Inscribed in a circle with a radius of 5. So here's my circle. My pentagon is inscribed in the circle. So there's my supposed to be regular pentagon inscribed in the circle. Patty, you're cruising for detention, buddy. Put the phone in the backpack. This is an awesome problem. This will be more fun than your phone, I promise. Find the area of the regular pentagon, and we know the radius of the circle is 5. Would you agree then that all of these are 5? What about all these triangles here? Ignore my picture. Remember, it's supposed to be a regular pentagon. What is true about all these triangles? They're all the same. So if I could find the area of one of them, I'd then multiply it by 5 and I'd have my answer, right? Okay. So in order to find the area of a triangle, I either need the altitude, or I need all 3 sides to use Hero's formula, or I need 2 sides and an included angle. Patty, I told you you would enjoy this if you paid attention. What?
Maybe divide 360 by 5 and then put them in the
Oh, Patty says, look, I got 5 angles right here.
And they all rotate.
That are all the same. And they add up to 360. So each one of them must be 72. Is that right?
Yeah.
That's right. So take a look at this triangle right here. What do I have? I have 2 sides and the included angle. So what is the area of the triangle? We have a formula. 1/2 side times sine of included angle. Now that's going to be the area of the triangle, so don't get too excited. It's 11 point something. But you want the area of the whole pentagon, so you're going to take that triangle area and times it by 5, and the area of the pentagon is 59.44 square inches. Or I guess they didn't tell me inches, square somethings. Now, next time you see that problem, it might not be a pentagon, okay? It might be an octagon. Is the strategy going to change? No. The only difference is, of course, instead of finding your central angle by dividing by 5, if it's an octagon, you would be dividing by 8, and then timesing the triangle area by 8. Or if it's a decagon, or, you know, whatever it is. Find the area of an isosceles trapezoid whose sides measure 5, 10, 5, and 12. So another flashback. Isosceles trapezoid. Sides measure 5, 10, and 12. So there it is. There's my isosceles trapezoid. there is a formula for the area of a trapezoid. You could do this problem without the formula, but does anybody happen to remember the formula? Okay, it's got a half, it's got a base 1 plus base 2 in it, and a height. That's exactly right. So if you remember, it's 1/2 height, base 1 plus base 2. So even if you remember it, you got a little work ahead of you, but that is the formula for the area of a trapezoid. You do not need to remember that, but certainly if you do, you can use it. Just like here, when you guys did these in geometry, you did not do them this way. When you did them in geometry, you have a formula, 1/2 apothem times perimeter, remember that? No, well, that's how you did it back in the day. We did it by splitting it up into triangles. If you want, could you split this figure up into different shapes? My personal preference would be to drop this guy and drop this guy. Now, it is an isosceles trapezoid, so what do I know about these two pieces right here? They are going to be the same. And since I dropped those down, wouldn't this piece be 10? Which means each of these is 1. So I could find the area of the triangles and the area of the rectangle there in the middle. And that's how you could do it without the formula. However, you still need to know the height, right? You still need to know what that is in order to find the area. Take a look right here. What do we have right here?
Right triangle.
A right triangle. And we know that's 5 and this is 1. So this must be, due to your Pythagorean theorem, that's C. So it would be what? Square root of 24, 2 root 6. A squared plus B squared equals C squared. C is 5. So now, if you just want to plug in your formula, you can. The area of the triangle would be 1/2 base times height. See, I'm not afraid to use that formula. I love that formula. If I have the height, I'm going to use it. The base is 1, the height is 2 root 6. So this is the area of that triangle. What's the area of that triangle? Same thing. What's the area of the rectangle in the middle? 10 times 2 root 6. So let's see. The triangle is root 6. The other triangle is root 6. And this guy is 20 root 6.
So this would be
22 root 6 would be the area of the whole trapezoid. That's what I said, absolutely. If you remember the formula, once you have found the height, you can plug it in right there and get your area. If you forget your area formulas, though, for these weird shapes, split them up into smaller pieces like we did here, and now I did this one here. Split them up and find your areas that way. Speaking of that, look at number 3. This is not anything like pentagon or anything like that. It's just some weird quadrilateral. Okay? We need the area of it. You're going to make 2 triangles. Now, obviously you got a decision to make. Are you going to make 2 triangles with this diagonal, or are you going to make 2 triangles with this diagonal? Anybody have a thought on maybe one would be better than the other? They will both work. You will get the correct answer either way. but I think one is definitely a little easier. Got a thought on that? I think it would be easier this way, because if I split it that way, I have a special triangle right here. This is a right triangle. And right triangles are special because there are things you can do with right triangles that you can't do with other triangles. Like the Pythagorean theorem. Like 1/2 base times height. If I call this triangle 1, his area is 1/2 24 times 18. That's it. The area of that triangle is already known. Base and height, right here, perpendicular. So all I need to focus on now is finding the area of the second triangle. All right. What are your thoughts on that? I need more information about the second triangle. You gotta find some stuff. So what can I find in the second triangle? Can I find the purple line? The purple line would be, I'll call it C. The purple line will be the Pythagorean theorem, right? So C squared equals 18 squared plus 24 squared. I think that might even be a triple. That's 30. So that works out to be 30. So now I know this side's 30. Now wait a second, kids, wait a second. I don't think I stand a chance of finding the height of that triangle, so 1/2 base times height is out. I have two sides, so now I need to figure out either the angle in between, or I need the third side. So, the angle. What's that angle?
2.5.
Oh, whoa. What assumption are you making?
That is half.
That the diagonal bisects the angle? That happens in a rhombus, folks. Is this a rhombus?
Nope.
No. So that angle has not been bisected. Do not go there. That is not bisected. However, let me call this angle right here X, this one. Could I find angle X pretty easily? Now think about it. This is a right triangle. Can I say something like tan X equals 24 over 18? SOHCAHTOA? Can I say that? I could also do the law cosines or the law sines or something else. But it's just easier for me. It's a right triangle. Tan X equals 24/18. So, how do I find the actual angle? Second tangent, 24/18. So this angle is 53.13. Now that's not the one I need though, right? The one I need is this one, so I'll just subtract that from 105, and I got 51.87. Now, what did I do that for? So I could find the area, because one of the ways I have of finding area is what? 1/2 side times sine of included angle. So the area of triangle number 2, one I already found. The area of triangle number 2 will be 1/2 28 times 30 times the sine of 51.87. One half side sine, remember that? Okay, so now I gotta find both of these and add them together. So the total area 46.38. Anybody match that? Now, I didn't need my law signs or cosines in this problem. I didn't need it. I could have used it because this was a right triangle. And remember, when you have right triangles, you have this additional pile of tools over here, the Pythagorean theorem and SOHCAHTOA. You don't need to use those. I could have used the law signs and cosines. It's just usually faster to use the right triangle tool, so that's what I did. I added them already. Yeah, I added them. Okay, all right, so now we got that. All right, good. You should be finishing up your homework.